Dear students and participants of the course on railway engineering, today we are going to continue a discussion on the interlocking systems. In this respect, if you remember, in the previous lecture, we started with the principles of interlocking. There were around 4 or 5 principles which we have discussed, and then there were standards of interlocking systems. There were 4 standards which were dependent on the speeds up to 50 kilometers per hour or up to 110 kilometers per hour, 140 kilometers per hour and up to 160 kilometers per hour. And there were different salient features with respect to those standards which we have discussed at that time. And towards the later time we discussed about the isolation of a track on which the train is going to move. And then what are the various methods in which that isolation can be done with respect to the sidings, with respect to the loop lines, and what are the various aspects which needs to be taken care of when the isolation is done. Now in today's discussion, we will be primarily focusing on 2 aspects of interlocking. One is key interlocking, another one is a mechanical interlocking. If you remember, in the previous lecture also we discussed something about the key interlocking in terms of operational conditions of the block and the block devices, and taking out a token and using that so as to either lock that particular section or we are going to release the section. So that is the type of an aspect which we are going to take in detail now. So as I said that there are different methods. So today we are going to talk about only key interlocking and mechanical interlocking, and the 2 other aspects which are electrical interlocking and electronic interlocking, which will be taken up in the next lecture. Let us start our discussion with key interlocking. Now this type of an interlocking system is one of the simplest method of interlocking. It is primarily dependent on certain devices and the authorization which is being given on the basis of the operation of those devices on either side of the line on which the train is going to be allowed to move. Now this is used on lines with a standard I interlocking, and when we say it is a standard I interlocking, it means the speeds are being limited up to 50 kilometers per hour. It uses a block instrument at a station, and this is provided on either side of the route, which is going to be set, locked and held for the movement of a train, and there are keys which are taken out of this particular instrument or which are being inserted in this instrument so that that particular route can be made operational or it can be released. On the right hand side you can see a photograph. This is one type of a block instrument. You can see there is a knob at the bottom. Then there are 2 things being shown here for the blocks. So either we are going to talk about a block which is on the right hand side, or you are talking about a block which is at the left hand side. That means a advanced block or a previous block in which the train may be allowed to move. It also has a phone being provided on the right hand side, as you can see here, and this phone is being utilized by the station master or the assistant station master who is being authorized to allow the movement of a train on a block. So this phone, they use it for the communication with the another station master or the person who is controlling the block at the other side. And after having the mutual conversation with each other, they decide that the train can be moved on this particular route and therefore it can be allowed, or the message that the line is clear can be given. So let us discuss a combination of the main line and the branch line to understand how this block system and the key system works. So very first thing is the points can be set for either of the 2 lines. It may happen that the train is moving on the main line or it has to go on a branch line. So on the basis of that what type of movement is going to be allowed, at this point the points and switches, they are going to be operated, they are going to be set. Again on the right hand side you can see there is another design of a block instrument which is used so as to control the movement of the trains on the lines. Now these block instruments, they have two keys, the key A and the key B. Key A is taken out when the point is to be set and locked for the main line, whereas key B, it is taken out when the point is set and locked for the loop line. So that is the difference between the two types of the keys which are being utilized. And on the basis of this key which is being taken out also, the personnel who are operating the system, they can understand that which particular route is being set and locked. At one time only one key can be taken out depending upon the route which is being set, that is whether the main line is being set or the branch line is being set. It cannot happen that both of the keys can be taken out together. So if it is being set for a main line, only one key, that is key A, will come out, and at this point the connectivity or the turnout which allows the movement on the branch line, it will not be set. So the tongue rails will be put in such a position that the train will keep moving in the straight direction. So there the key A is going to be taken out of the block instrument. Then the lever frame operating the signals has two levers, lever for main line which can be operated by using the key A, and similarly there is another lever which is used for the loop line and it can be operated with the key B. When we say we are operating it with the key A or key B, it means that key A or key B is going to be inserted there and then it will make that lever operational. So that means when you do not get two keys simultaneously together, that is key A and key B are available to you simultaneously, once they are not there, obviously the levers can also not be operated. So this is a mechanism that it should not happen that by mistake you operate some other lever. So this is how they have been designated. Therefore, if the train is to be taken on the main line, the points are set and locked for the main line and the key A is released from the block instrument. And this key, now once it is being released, it is used for the interlocking the main line signal lever, thus lowering the signal for the main line, that is it is going to put it to off position or will give an indication that now the train can proceed on this particular section. So I just repeat that how you are operating it. You are operating a block instrument which is provided at a station, and then on the basis of which particular side is to be operated, accordingly it is going to work with respect to the train coming from or going to conditions, and then which particular line is to be operated or which particular line is going to be set. Once that is being decided, then we are taking out a key on the basis of that, either the key A or key B of the block instrument, and here once it is being taken out and before that the points are set and locked. Now this key is used so as to release the lever. So levers are again being designated by key A and key B, and once the appropriate key is being used either to release lever for main line or a branch line, the signals with respect to either of those two will be down. That means they will allow the train to move. So that is how the things are going to happen. Now since KE cannot be used for interlocking the signal for the loop line, this type of interlocking is also known as indirect locking. That means you have indirectly locked the loop line. Now loop line cannot be taken into consideration, the trains cannot move on that particular loop line. Now in case more than one point is to be set and locked, because it is a long route, but there are number of sections which are coming out of this particular main line, and therefore if within a particular distance so many points are going to occur, they are being provided on the track, then they needs to be set for the movement of train from point A to point B or point 1 to point 2. So, in that case how it is being done? So, that is being talked here. It says that if more than one point is to be set and locked, the key released at the first point is used to unlock and operate the second point, and then the key will be released at the second point, which will be used at the third point, and so on. It will be done till you are reaching up to the location 2. The key released at the last point is used for unlocking the lever operating the appropriate signal. So, that is how in successive manner, because you are operating and you are locking the system, that is why this particular system is also known as a successive locking system. So, we have two types of a locking. One is indirect locking, which is being used so as to lock the loop line when the main line is being set, or vice versa. And another thing is that on the same track, if number of points have been set by using the successive keys of the previous point or previous block, then in that case it is a successive locking. It is used for checking the conflicting movements in shunting. So, in the case of shunting, the engine or the locomotive along with the wagons may be moving from different lines or sidings to the main line or to any other line which is going to be set. So, in that case also this successive locking system is utilized. Here again there is another photograph which is being shown for the blocks which are used, the block instruments which are used so as to operate and get the keys. Now, another system is a mechanical interlocking system. Now, in the mechanical interlocking system, we are going to operate the things with the help of the levers and the connecting things with that lever, which is finally going to the signal. So, this is an improved version of interlocking as compared to the key interlocking. Here the lever frames are provided which are connected by wire to the signals and points. So, if you see in the right hand side, on the right hand side there are 4 levers which are being shown here. So, these are lever 1, 2, 4, and at the bottom there are horizontal bars which are being shown. So, these horizontal bars, they are basically the frames which are being used for the locking of the various tappets, and then again at 90° of that there is another arrangement which is being provided, wherein the tie bars are there, tappets are there, they are being connected. In one case 3 things are being connected, in another case there are 2 such tappets will be there, and then all of these levers, they are finally getting connected by wires to the track and to the signals. Now, when we say it is being connected to the track, it means we are talking about the points which are going to be set. So, these points which are there, say if we are talking about a track which is having a straight section and a curved section, that is a turnout is being provided here. So, in this case this point is going to be set with the help of lever 3 and 4, whereas when you operate the lever 1 and 2, then they are being joined to the signal systems, and depending on whether you are setting for the main line or you are setting for a say loop line or for a turnout, accordingly either the signal 1 or the signal 2 is going to be operated. So, this is an overall mechanism in which the things are going to happen. So, when we use this mechanical system, here in this case lesser staff is required and the safety is better as compared to the previous system. Now, what are the constituents which will be there, as we have just looked at on this particular diagram on the right hand side? It is having a locking frame. Locking frame means it has the signal levers, it has the point levers and the point locks. So, here that is 1 and 2, they were the signal levers, and then 3 and 4, they are basically the point locks or the point levers. Then there are point fittings, there are plungers, tappets and the lock bars which are available in this area. So, if you see here, there is a one tappet at this point, there is another tappet, then there is third tappet and fourth tappet here, then there is another tappet on the other side, as well as this is another one. So, these are the number of tappets which are provided. Then these horizontal arms, these are the plungers, and you can see here that there is a notch. So, this notch will move up and down. Say if you are having a lever, you are putting the lever back. So, this plunger will move in the forward direction. So, when it moves in the forward direction, then this notch will come in front of the tappet, and as soon as it comes in front of the tappet will move into that particular notch, because tappet has been held with respect to the edge of that plunger. So, it is forcing that. So, at this time it is being restricted. So, when it is being restricted, accordingly the point setting or the signal setting is going to be different, or it may not be set. So, as soon as it gets into the notch, then it will change the system, and when it gets into the notch, because here 1, 2, 3 and 4 tappets, they are connected with each other by using a tie bar. So, what happens is, as soon as one enters, the some other one is either going to be released or either going to be locked. And similarly, when the other levers are going to be moved, the tappet on the other side, that is one tappet here and the other tappet on this one, that is A and F being marked, they will also move accordingly. Now, plungers have notches, as I have already shown to you, and the tappets tie bars are placed at right angles to the plunger in the notches. So, these tappet tie bars are there. So, this is a tie bar, and on that the tappets are being attached. So, they are at 90° to the plunger. So, plunger is moving up and down here, but tappets and its tie bar is lying in this form. The plungers and tappets, they are arranged in the locking trough. So, you see here, this is the locking trough in which these are going to move. So, one tie bar is going here, another that system is working on the other locking trough. Now, each lever is attached to the plunger, which has suitably shaped notches to accommodate the locking tappets. So, this plunger, as I said, for each lever. So, this is one combination, this is another, this is third one, and that is the fourth one. So, these are connected with each other, and these plungers have the notches, and as you move them, the tappets and notch adjustment is going to be there. The lever, plunger, tappet and tie bar combination, they works on the wedge action. Wedge action means this type of a system, if it is provided, then that is a wedge. So, as soon as there is a tappet which is resting here and which may be connected with the tie bar with the another one. So, if this plunger moves, what will happen, that at this moment it is being resting along this surface. So, it is omitting that surface and it is being restricted from the movement, but as soon as this is going to move, the plunger is going to move to the left hand side, then this tappet will move into the wedge, because now this notch will come in front of the tappet. Now, due to this type of an action, the lever, when it is pulled, it moves the connecting plunger, it pushes out the tappet of the notch at right angles to the movement of the plunger. So, it all depends. The another thing which can happen is that if already there is a tappet which is going inside this notch, then in that case, if this plunger is moved back and forth, so it will be pushed out of the notch, and it will pushed out of the notch, then in that case it will be resting in this form. So, it all depends again that in what particular form you are moving the levers, accordingly the setting is going to be there. So, the previous types of the levers which used to be there were like these, more sturdy but difficult to operate. The another one which you can see on this photograph, they are a bit easier conditions, can be operated more easily as compared to the previous versions. So, here in the photograph being shown on this slide, what you can see that there are lever arrangements, where in some levers they are in the normal condition and the another lever which is being pulled either forward or backward depending on how the setting is going to be provided. And with respect to that, then there are connecting rods, and these connecting rods are operating the system at the point. And similarly, the another connecting rods and wire system will be there, which will be going towards the signals, and on the basis of the way the levers have been operated, the signal is going to be either put in an off position or in on position. Now, the movement which is being done at this lever frame arrangement, this gets transmitted to other tappets which are connected to the previous tappet through a tie bar. I have already talked about this and shown to you those things. The other tappet either gets pushed into or out of the respective notches of the other plunger, and depending upon the interlocking done, that means when we say depending upon the interlocking done means for which particular line we are going to set and what we are going to set, which particular point we are going to set. So, on the basis of that, if another tappet is free and slips inside the notch of the other plunger, then it locks the lever connected with that plunger. So, in one case it is released, in another case it is locking. So, the system is being created in this form that if we are releasing at one point, it is getting locked at the other point, and that is what we discussed whenever we were talking about the key interlocking. There also we said the once the key has been taken out and say the it is a key A and we put in lever A or lever 1 which is related for the main line, then the branch line or the loop line cannot be operated, it is got locked. So, it is a indirect locking system will be there. However, if the tappets are already positioned in the notch of the plunger, that means it is locking the lever, it will come out of the notch and the connected lever will get free. So, it all depends whether you are going in or you are going out of the system. So, this whole arrangement is shown here. So, that is what it is saying is that if you are moving and here if this tappet is in the notch and if you move it, then what will happen, this tappet will go out of the notch, and when it goes out of the notch, now this is connected through the tie bar to tappet B and tappet C as well as tappet D. So, it may happen that tappet D will come into the notch, but at the same time the other notch other these tappets which are there, they will get operated. So, either B or either C, it will again get into the operational system, and one will be locked and one will be released. Now, again let us look at an example here. Consider a two line railway station, one line is for main line, another is for loop line, and there is a home signal 1 which is operated by lever 1 and the home signal 2 which is operated by lever 2. So, there is a signal 1 and the signal 2 here. So, signal 1 is connected to the lever 1. So, this is L1 and this is another L2. Now, lever 3 it sets the point 3. So, here this is a point if the turning is to be done. So, it is connected with the lever 3. So, this is lever 3, you can see the connection is coming up to this point. And it is going to be set as soon as the loop line over which it is there. So, if you just pull the lever 3, then that can be set. Then in pulled position lever 4 it locks the point 3 in either position, whether it is going to be normal or it is going to be pulled. It means either it is going to be set for the main line or it is going to be set for the turnout. On the basis of that, this lever 4 is going to work. It is a locking arrangement which will be there. If you remember, we talked one lever is a point lever, another is a lock lever. Now, both the signals 1 and 2 cannot be put to off position, that is the principle behind the interlocking system. So, both cannot be operated together, only one is going to be put to the proceed condition. It means the train can be received either on the main line or a loop line at any point of a time. When the plunger 1 is pulled, then the tappet A is forced out of the plunger and moves into the notch of the plunger connected to lever 2. So, what will happen is if you are pulling this plunger 1 here, lever 1 here, then when this lever 1 is being pulled, so here this tappet which is provided here as it is going into the notch, if you can see, it will get released. So, tappet A is forced out, and the another thing which happens is that this moves into the notch of the plunger connected to lever 2. So, once it is being freed, so there is a notch on the plunger 2, it will get into that. Now, when it get into that, now it is going to lock here. Now, this prevents the lever 2 from getting pulled. And similarly, if now you are pulling the first of all you have to release the things using a lever 3 or 4, because 4 is a locking arrangement system. So, once you release it, then the other way can also be done. The point will set for the main line if lever 3 remains in normal position and lever 4 is being pulled. Okay, so it means now if lever 4 you pull, so what will happen? Lever 4 is a locking arrangement. So, now it is going to lock the system for main line. In normal position of lever 4, tappet D, it butts against the plunger and does not allow tappet B or C to get released from the notch. So, here let us look where is tappet D. So, this is tappet D here, this is lever 4. So, if it says that in the normal position it is butting against the plunger, you can see that it is not going inside the notch, it is just touching the plunger. Now, when it gets operated, this notch will come in front of this tappet and this tappet will move into it. Now, as soon as this moves into it, this will not allow the tappet B and C to get released from the notch, because now when you are talking about this tappet D, this is connected with B and C by using a tie bar. Now, pulling of lever 4, it brings the notch in front of the tappet D, thus releasing tappet B or C as required. Now we will do what? We will pull it. When you pull it, then the B or C, depending on which is to be going to be set, will get into the system. Also, tappet E will move in notch of plunger connecting lever 3. So, simultaneously there is a movement of different tappets into the notches, and that is going to create a system of a setting as well as locking. The position of lever 4 can be restored only if the lever 1 or lever 2 is brought back to the normal position. So, once it was set either for a signal for a main line or a signal for a loop line. So, if it is being restored back, then only the lever 4 it can be restored. Now, lever 1 or lever 2, they get released by pulling the lever 4, which in turn locks the point. So, as I already said, the lever 4 is a lock lever. Now, the movement of tappet A also causes the movement of tappet F. So, here this is tappet A and this is tappet F. So, as soon as, because these two are being connected by a tie bar. So, if one gets released, the other is locking, which moves into the notch of the plunger connected to lever 3, thus locking it in the position. Now, if you have to adjust the track for the loop line, then what you are doing is put back the lever 1 in the normal position. Now, this will allow the tappet A to enter the notch on plunger connected to lever 1. So, tappet A will get into this notch. So, once it is being done, it is getting locked, it will not move. Then lever 3 is pulled to set points for the loop line. So, this is a point lever, so it is being pulled. When you pull it, then the tappet E is going to move. So, when this tappet E moves back and the lever 4 and tappet F moves out of the notch on the plunger of lever 3. This will lock lever 1 due to movement of the tappet A in the notch of plunger of lever 1. So, simultaneously movements you can check here, and accordingly you will get an idea that how it is happening. Now, lever 2 is pulled, causing movement of tappet C in the notch and bringing signal to off position. So, now you have set the signal, the point was already set, and therefore, the train can be allowed to move on the loop line. Now, there are other things related with this type of an interlocking system, because of the levers which have been operated. Now, they have been connected through the rods to the point system. So, when you are setting the point or when you are locking that particular point, so here different type of things which are provided, they will move, they will lock the system for the movement of a train on either on the main line or the turnout. So, here first of all let us look at what are the things. We have already talked about few of things previously. So, this is a main track and then we have the tongue rail provided here. It is being connected by the stretcher bars. So, there is a point lock system provided at this point, there is a plunger and then there is a timer crankway is also provided at this location, and this crankway by way of the rods is connected here and it is going to the lever frame. Similarly, when you are talking about these stretcher bars and the tongue rails which are going to be operated in either direction is attached here, and through this it is going to the point rod, that is the lever 3. So, if at once now when we talk about the detectors, detectors are what? It tries to give you an idea where the train is. So, it once detect any defect or failure in the connection between the switches and the lever or an obstruction between stock and the tongue rail. So, if any such things is there, then it is going to show and going to give an indication to the people who are setting it, and they have to first of all rectify that. The signal remains at danger position and cannot be taken to off position unless this particular defect is being set. Detectors are used on all points over which the signal controls the train movement. So, these are a safety feature which has been provided at this particular location. Then stretcher bar, the two tongue rails which are connected to each other by the means of two straight bars which are known as the stretcher bars. The front stretcher extends under the stock rail to prevent jumping at switches. So, this front one it is going to be extending. Then there is a temperature compensator. This is used to neutralize the effect of expansion and contraction of the rods due to variation in temperature. It consists of a pair of cranks. So, here these are provided, one of acute angle, another for obtuse angle, and connected by a pipe. So, they are being connected through a pipe system here. Then there is a point lock. So, we have shown this point lock here, and this point lock again it is going to be connected through the rod system to the point lever. It ensures that each switch is correctly set. It is placed in the middle of the track, a little in front of the toe of the tongue rail. So, the tongue rail toe is here, it is coming up to this point. So, after that then we are having this point lock. It consists of two stretcher blades, a plunger casing and a three-way crank. The different types are a bolt and cotter, each individually fitted to switch rail and padlock or clamp, and a padlock for locking switch rail to the stock rail, and here the speed is less than 16 kilometers per hour when it is going to traverse on this particular section. The another one is the key of approved design for locking each rail independently when the speed is more than 60 kilometers per hour and less than 48 kilometers per hour, and the third one is a plunger type for the facing lock for a speed of greater than 48 kilometers per hour. So, as I said that this whole system which is being provided, so there is a tongue rail here and a stock rail on this side, and now the movement here they are being controlled by way of these pipes and the systems being placed here. So, the connecting devices usually consist of 3.8 centimeter diameter pipes or the solid rods. These move on rollers in frame fixed in concrete at 2 to 3 meter interval. The distance between a cabin to point or signal should not exceed 275 meters. So, because now this is going to be connected to the cabin from where the levers are operated. So, in that case the distance should not be more than 275 meters. Lock bar. This lock bar is basically there to ensure that the point is not operated while the train is moving on the section. So, it helps in the locking system. It is little longer than the longest wheelbase of any vehicle. So, whatever bogie sizes are being used, on the basis of that bogie size whatever wheelbase is there, it is longer than that. It is provided near and parallel to the inner side of the rail. So, this the inner side of the rail. So, this lock bar is here, it is provided on that side. When the point lock is worked from the signal cabin, the lock bar rises slightly above the rail level and then comes down. Means when it is being operated, it will first of all go a bit up and then will come down. Then slotting of signals. Now, this is an arrangement in which the lever operating a signal in one cabin, but the actual taking off of the signal requires releasing of the control from the another cabin. So, you are not doing everything at one location. Now, if we talk about the advanced systems, the things can be set from one location itself, but here we are talking about a cabin system, and this cabin system, now the signals are slotted. Slotted means whatever number of tracks are being provided, accordingly for which particular track which signal is going to be operated is what we are talking, and that is what is known as slotting. Now, both of these cabins can unilaterally put back the signal to danger position. So, they can put any signal to danger position, but if we are going to release them so that the train moves on that, then in that case it is going to be operated with a combination of both cabins. The arrangement of slotting is done either electrically or mechanical, both operations possibilities are there. The slotted signal cannot be put to off position unless the control from all remote locations have been operated. So, as I said, because if it is being operated for multiple cabins, then all cabins have to be working in the sync with each other, and then only this can be happening. So, purpose of the slotting is twofold: ensure that the points located on the line controlled by a signal, including the overlap, are set correctly and facing points locked, and a line is clear before the signal is put to off position. So, we are taking complete safety measures in terms of again repeating the same thing, that setting the points, then locking them and holding them before we are putting it to off position, then only the train will start moving, and the condition is maintained until the train movement is completed. After that only it will be converting into an off position, and the operational system will get activated again to put or release the system and so as to receive the new train. Now, following types of controller slots are in use on the mechanical interlocking: the mechanical lever worked by the key which is transmitted electrically, or the electric lever lock, or the electric signal reverse post type. So, these three different type of systems are there, but we are not going into the details of these systems here. We need just understanding that what are the various systems. Then station master is given the slot control over the home signal, last stop signal and calling on signal if it is being provided. So, who is going to have an authority? This is fixed. Accordingly, the operationals will be done. With this, we close our discussion now, and what we discussed was two aspects. One is the key interlocking aspect, another is the mechanical interlocking aspect. And apart from that, we have also discussed about the various mechanical devices which are used when we are setting a point and locking a point or holding a point for the movement of a train. We will be continuing our discussion on these interlocking systems in the next lecture. Till then, thank you and bye.